I thought I'd start off this presentation, and I labeled the presentation contextualizing the SAGO, just to give you a sense, and just to indicate the overview of the presentation, the strategic context, which gives birth to why we're here in the room. And then look at the group on Earth observation, and then specifically at the SAGO initiative, and then conclude with a summary. Just in terms of the strategic context, now we started this work around about 2008, and the strategy which I'm talking about now was actually approved in 2010 and launched in 2010, together with the National Space Agency. And I thought I'd just start off with this particular slide, which kind of gives you a sense as to what we were trying to do with the National Space Program. So essentially, if you start at the top, what we did is we've got a whole group of government departments in the room together, and there are essentially about 30 or different government departments. And we asked them to articulate to the DST, to the Department of Science and Technology, essentially what their requirements would be from a national space program. And then there was a whole series of user requirements that emanated from that exercise. And then what we did was that we started to cluster user requirements into 3 key focus areas, which we call environmental and resource management, health, safety and security, and then innovation and economic growth. So we took that as our starting base, as the user needs driving the whole space program. And then we started to identify the various thematic areas that would support those user requirements. And then we decided that we would be focusing on Earth observation, communications, navigation, and then space exploration. And then when we started to drill even further down, the functional platforms that would need to service those thematic areas was trying to come up with the various mission requirements. If you had a satellite program or wanted to acquire satellite data, you needed to articulate your mission requirements, various technologies you need to put in place, so we needed to invest in R&D, technology development. And once the various platforms are functional, you then need mission operations, which currently sits at the former Satellite Application Center, which is now Sensor Operations. And then, last but not least, is to invest in space applications to respond to the user requirements. And then in order to service those functional platforms, you need supporting platforms. You need the necessary infrastructure, you need the people, you need specific international partnerships where there's gaps in your system, and then you also need industrial participation and development, because government cannot drive the national space program alone. It needs the private sector to do that. And then on the side, we recognize that space awareness was very critical to the whole process. This particular slide actually captures what we were trying to achieve with regards to Earth observation, and I see, Terry, you put it in your the presentation outside. Essentially what you needed to create, if you start on your left-hand side, was a national archive, and then you needed to create a portal which kind of is built on that archive. And so the portal looks at different observing systems, draws data from various platforms. And then you have a series of data repositories. And you integrate the observing systems with the data repositories through what is called the SciS portal, and I'm sure you're going to hear a lot more about that today, so I'm going to spend a lot of time. But once you set up this particular infrastructure, you then set up what I call the people aspect. So you have a data processing center of competence. We haven't done that as yet, but I think this is where we want to move towards. You invest in research and development and human capital. So you use that particular platform to do R&D and also to develop human capital. As I indicated when I started off with the first slide, is that the user requirements was the critical aspect of the space program. So the goods and services, for which there are 3 different categories. So the core goods is essentially responding to government's needs. And when I talk about government, I talk about national, provincial, right down to local municipal level. And then there are certain products that you want to develop for public goods. And I think we'll hear about some of the societal benefit areas, which I would consider to some aspect the public goods perspective. And then you also allow the private sector to generate profits and so on from delivering products and services. So just taking that slide and just trying to unpack it in this form. Essentially what you want to do is set up an Earth Observation Data Center, which is an archiving center, a data processing center, and then you want to create a user interface portal. And so essentially those three, together the fourth one, is what gives rise to the science portal. Then you want to ensure that there's adherence to data access and sharing principles and train research and researchers and practitioners in order to use that particular platform. So that's essentially what we're trying to do through the EO value chain. So that's just up to now just trying to contextualize what our thinking was with regards to setting up the National Space Program. Now, just to contextualize SA GEO, I think it's important for us to go back and understand what GEO is about. So this is about the group on Earth observation. I'd like to thank Imran for putting the next few slides together. I think he borrowed it from a paper by Stefan et al. In 2007. But essentially what the next few slides show is how activity sort of started to accelerate around about 1950s. So if you look at the population growth, it started to kick off in 1950. The total real GDP, that's the economic growth, started to accelerate around about 1950. International tourism, same pattern. Damming of rivers, water usage, fertilizer consumption. So you see, contingent with the population growth, the consumption also started to increase. And then some other aspects in terms of consumption, there's urbanization that started to happen around about the same time. Paper consumption started to grow around about the 50s. The number of motor vehicles on the road, communication, telephone lines also grows around about 1950s. And then if you look at the biophysical system, a whole series of other platforms, the fisheries that was fully exploited also kicked off in the 1950s. Coastal zone structures, loss of tropical rain, domesticated land, global biodiversity measured by species extinction. All of this kind of kicked off around about the same time in the 1950s. And then some effects on the atmosphere. Again, I'm not going to go through the individual parameters, also around about 1950s. So what that tells us is that as the population starts to grow and consumption starts to grow, we start to have an impact on the geosphere, biosphere. And so mankind has become a geophysical parameter. It's essentially changing the landscape itself. And so geophysics has become a political and economic issue. It's kind of relating to the last few slides. But what is actually necessary in order to track all of those changes is that we need Earth observations to inform decisions. But what I think is core to that whole issue is the issue of sustainability. Because if you look at it from a systems perspective and the influence that man has in the environment, you've got to ensure in terms of sustainability the elasticity of the system. Because at some point you would lose the elasticity and you would just go into irreversible mode. And I think this is what is important. So having Earth observation to inform us to make appropriate decisions, especially around sustainability issues, is very important. So given the last few slides that I've put up, you actually need a very integrated approach in terms of assessing the impact of man on the environment. And so, this is essentially a coupled system. Everything, impacting the oceans influences the atmosphere, influences the rivers, and so on. So, this is a multi-variable kind of problem that we're dealing with. So modeling this is very important. So this essentially gave rise to the need for a group on Earth observation in terms of a systems approach. So we must understand Earth as a system. Okay? It's an Earth system. So knowledge of the Earth system is fundamental for economic and social decision making. And then the economy is a huge amount tied to the environment. So sustainable mining of your resources is very critical to the economy because it's, at some point in time, it becomes unsustainable. So the Group on Earth Observation was born in July 2003, and this was the first inaugural meeting in Washington, DC. And what we put down here is essentially the member states, member countries to GEO. And as you can see, there's a huge gap in Africa and there's some gaps in South America as well. But currently, GEO comprises of 88 members together with the European Commission. And there's also 61 participating organizations. So it's quite a huge endeavor internationally. If you read the 10-year implementation plan, I think there's a booklet out. I saw that in the exhibit next door. What GEO was trying to do through this plan was trying to unpack this whole system. And so it came up with these 9, what we call societal benefit areas that looks at health, energy, climate, the ecosystems, biodiversity, water, weather, and so on. So those are the 9 societal benefit areas. And what you're trying to do is take a coordinated, comprehensive, and sustained look at the system by looking at different aspects. But you still need a systems approach. So the whole notion of a group and Earth observation system of systems was born. So you look at the principles of GEOS, the Group and Earth Observation System of Systems. It was essentially set up to revolutionize our ability to understand and manage the planet as a systems, interconnecting existing and future Earth observation systems. And we've essentially setting up the SARS portal back home. And so if you look globally, there are many subsystems that exist. So you want to kind of plug in all of these different systems together. We want to reduce costs and promote international cooperation and serve the public good. We also recognize that there are many countries that don't necessarily have this sort of resource. So how do you take an international initiative like this and ensure that those developing countries that don't have access to the resources to develop such systems have access to such data? Because as you can see from the last few slides, being able to sustain, manage your resources in a sustainable manner is very important, especially to developing countries. How do you take technological advances and make that possible, use it for developing such a system, but also understanding that the user needs actually make this particular initiative necessary? So it's taking the technology and applying it